Fireworks, those bright bursts of sound and light you see on the 4th of July, are classic examples of physics in motion. They're perfect illustrations of projectile motion, electron behavior, and momentum. A lot of science goes into making that display of pretty lights. The three main ingredients of a basic firework are sulfur, charcoal, and potassium nitrate. Potassium nitrate is an essential part of gunpowder. It is what makes the firework explode. Sulfur and charcoal mainly serve the purpose of being the firework's fuel. There are 4 parts to a firework: the container, which is usually a cylindrical part that holds the firework; the stars, which are shaped like cubes, cylinders, or spheres, and make up the firework's pattern; the charge, which is the part that makes the firework explode, housed in the center of the shell; and the fuse, which ignites the charge and ensures that the explosion happens at the correct time. The sparks in fireworks are the result of igniting small pieces of iron or steel. Color in fireworks is determined by burning metal salts and oxides. The color is dependent on the type of salt burned. The two chemicals react to create the colors. When the charge detonates, it heats the atoms of the compounds. The heat energy causes the electrons of the atoms to rearrange to a higher energy state. When the electrons jump back down to their lower energy state, the expended energy is emitted as light. The amount of energy given off decides the wavelength and therefore color of the explosion. The hardest colored firework to create is blue. The reason for this is that the compound that produces blue, copper chloride, does not work well with hot flames. A few decades ago, the blues you would see would just be dark purple or more on the green side. Discoveries of new compounds that work better with heat energy and has made it possible to create blues more true to their color, but blue is still the most difficult color to produce in a firework. Making shapes with fireworks illustrates Newton's third law of physics. For every action, there's an equal and opposite reaction. When you order the stars a certain way and place the charge in the center's charge detonation pushes the other charges out in equal and opposite directions. Therefore, physics is used when constructing the shape of the fireworks. It is also possible to split up the design so that the stars aren't all in the same place. When you design the arrangement in that way, you get different patterns because the stars don't all detonate at the same time. Many fireworks are named after flowers because they break out of a seed, their shell. The most common type of firework is the peony firework, so that's the one we'll look at first. It's the most common because it's easy to make compared with the ones that explode into specific shapes or leave certain trails. Peony fireworks are the easiest because they don't need any special modifications to make their shape. The star is just arranged in a simple circle. According to the laws of physics, in a detonated explosion, force will travel equally in all directions from the explosion. This is perfectly exemplified in a peony firework. Since there's so little resistance in the air, when the peony fireworks shell explodes, it creates a spherical shape. A more interestingly shaped firework is the Roman candle firework. This one is built with a long, narrow shell and bigger stars. They're spaced farther apart so that they go off at different points. Another type of firework is the mine firework. It's set off on the ground and shoots its stars into the sky. Similarly, glitters are fireworks that are shot from the ground that explode into sparkles. Fireworks, no matter their shape or color, also demonstrate the principle of momentum conservation. Before the firework explodes, the total momentum in the system is 0. After it explodes, the sum of the vectors of its fragments is still 0. Fireworks are exciting examples of how physics works.